Hi, my name is Gavin Ruane, and I'm a student in CPE 133, Section 7. This is my final project individual submission video. In this project, students were tasked with creating a 4-bit multiplier on their Basis 3 boards. This was a pretty cool project because we actually got to combine many of the things that we learned about this year into one final project. We used an FSM that we created ourselves using a state diagram, which I'll show right now. We also used a shift register, which we learned about in class, an accumulator, as well as the universal segment driver created by Dr. Mealy. We used all of these modules together to create this 4-bit multiplier, which is pretty cool. I'll include my test cases later in the video and also show them here, and I'll show any other relevant data that might be necessary for you to understand this project. Otherwise, that's it, and stay tuned for my test cases. All right, so let's get into our test cases. So before I actually do the test cases, I just want to go over a few things with how this multiplier project is going to actually work on the Basis 3 board. So first, I just want to point out that we're going to be using switches for our inputs, just like the RCA and advanced calculator and even the sequence detector. So these 4 switches right here that I'm highlighting right now and that are highlighted down here correspond to input A, and the leftmost is going to be the 3rd most significant and the rightmost is going to be the 0th. And it's the same concept for these 4 switches, the farthest to the right over here, but these are going to correspond to input B. And then one more thing, again, just like our advanced calculator, we're using memory in this project, so the value will be stored and it will show and persist on the display until you hit enter for the new calculation. And that's just going to be the center button. That's the only button we're using this time. Okay, so that's enough of explanation. Let's actually get into the test cases. So let's do 0 times 0. Well, we're actually already in this position. As you can see, everything's in the 0 position. I'm going to hit enter, and it's going to be 0. That's perfect. Okay, now I'm going to do 0 times 5. And of course, we didn't see a change because anything times 0, or 0 times anything, is 0. Okay, now let's do 9 times 0. So that's going to be this. Enter, and again, we're not going to see any change. Now, here's an interesting one. 6 times 1. Enter, 6. That's correct. 12 times 2. And that's 24. That is perfect. Now, let's do 9 times 4. 36. So as you can see, this project is actually using, it can display values that are greater than just the ones that just take up 1 digit, which is pretty cool. Okay, so now let's look at 10 times 8. Enter, 80, that is correct. 11 times 3. 33, correct. 7 times 6. 42, correct. 14 times 12. Enter. 168. That's one I had to look up, but it is correct. 13 times 7. 91, correct. 1 times 14. 14, correct. And for our final test case, 15 times 15. So we're just going to actually turn on all of the switches. Enter, 225, correct. So in this project, that is the greatest value you can actually get because you can't actually make a number with the switches bigger than 15. So that's our max value. All right, well, that's it for the test cases. I have passed them 100% completely. And that's it for the multiplier project. Thanks for watching my final project video, and I hope you have a great day.